Good morning, all of you. Now, today we are going to study about the distance time graph for uniform motion. Okay. The following table shows the distances covered by a car in fixed time interval. Draw a graph of distance against time, taking time along the x-axis and distance along the y-axis. Okay. So you see here, graph is given here. We have taken on x-axis time and on y-axis distance in meter. Okay. So you see here 1 centimeter is nothing but 10 second we have taken. Okay. Then 20 second, 30, 40, 50 in this manner. And on y-axis we have taken 1 centimeter is 20 meter distance. Okay. 1 centimeter is 20 meter distance. So 20, 40, 60, 80, 100, 120, 140. Okay. Now here in this table it is given now for 0 second 0 meter is there. Okay. Then for 10 second 15 meter. Okay. For 10 second 15 meter. Okay. The car covered 15 meter in 10 seconds. So in 20 second it covers 30 meter. In 30 second it covers 45 meter. Then in 50 second it covers 75 meter. In 60 second it covers 90 meter, and in 70 seconds it covers 105. Then you see here we have taken points on that particular, and we draw the graph this. Okay, straight line comes. Okay, so just you see when we have taken distance time for uniform motion, the graph shows a straight line. Okay, next. Now we will see the distance time graph for non-uniform motion. In the first case we have seen distance graph for uniform motion. Now here we are going to see about non-uniform motion. What is the position of graph? Now the following table shows the distances covered by a bus in equal time interval. So draw a graph of distance against time, taking the time along the x-axis and distance along the y-axis in figure 1.6. Does the graph show a direct proportionality between the distance and time? Now we will see now. Now you see here on the x-axis we have taken the time, and on y-axis we have taken the distance. Okay. Now here 1 centimeter is nothing but 5 second. Then 10 second, 15, 20, 25, 30, 35, 40. On y-axis we have taken 1 centimeter as 10 meter, 20 meter, 30 meter, 40, 50 and 60. Now let us see now from the graph, from this table we will plot the graph. Now for 0 it is there. Now for in 5 second it covers 70 meter. Okay, the bus covered the distance of 70 meter. 5 second 7 meter. Then in 10 second it covers 12 meter. In 15 second it covers 20 meter. In 20 second it covers 30 meter. In 25 second it covers 41 meter. Then in 35 second in 30 second it covers 50 meter. In 35 second it covers 58 meter. Okay, and now you see I have taken points on this. Okay, then you see the graph, we are not getting a straight line. Okay, so we are getting a curved line in this. Okay, so this is the case of non-uniform motion. Now next, velocity time graph for uniform velocity. Okay, now we will see velocity time graph. Okay, so now a train is moving with a uniform velocity of 60 km per hour for 5 hours. The velocity time graph for this uniform motion is shown in the figure 1.7. So what they are telling, that the train is moving with a uniform velocity of 60 km per hour for 5 hours. So it is running for 5 hours. Okay. So what are the question they are asking? Now you see, just see this graph. Here time is there on the x-axis and velocity on the y-axis. 1 centimeter is here 1 1 hour, okay, then 2 centimeter 2 hour, 3 hour, 3 o'clock, 3 hour, 4 5, okay, in this manner. Then on velocity, kilometer, 10 kilometer year, okay, 20 kilometer, 30, 40, 50, 60, in this manner, okay. Now with the help of the graph, how you will determine the distance covered by the train between 2 and 4 hours. So what they are telling, the how much will be the distance between 2 hours and the 4 hours. We have to calculate this, okay. Then is there a relation between the distance covered by the train between 2 and 4 hours and the area of a particular quadrangle in the graph? What is the acceleration of the train? Okay, now you see here we have given here the graph also. You see the dotted line, the speed of the train is 60, velocity is 60 km per hour. It is shown here, okay. And this we have to calculate the distance between the in this C and D, okay. Okay, so now you see the velocity is AC and BD, okay. This is the velocity. If you just consider in the quadrangle, okay, this is the quadrangle AB and DC, this is the quadrangle, okay. Now I will explain you in the graph manner. You see here, velocity is given here. Velocity is nothing, we know that this formula velocity is nothing but displacement upon time. So I can write this V is equal to S upon T. So to find the displacement, we have to find the displacement. So S is equal to V into T, velocity into time. So S displacement is nothing but 60. Velocity, the train is moving with a 60 km per hour, okay. So 60 into T2 minus T1, okay. What is T? T2 minus T1, here see. Here T2 minus T1, we have to find this time between this 4 hours and 2 hours, okay. So we will 60 into 4 minus 2, okay. So just you calculate this, 60 into 4 minus 2 is 2. So that is nothing but 120 km per hour. We got this, okay. Now from graph we have to find, okay, from graph presentation of the graph we have to find. So V is equal to AC or BD. You see here V is equal to, I can write in the form of graph AC or BD, okay. So I have written, then time T2 minus T1. So that is, here you see T2 minus T1 means T2 minus T1, that is we can say that is DC, okay. This is DC, okay. So I will write S is equal to AC, or that is V into T, so that is T2 minus T1. So I can, so AC as it is and into T2 minus T1, that is I can write in the with the help of graph DC, okay. So that I can, now again I will write the value of AC. Value of AC is nothing but 60, and what is the value of DC? That is 2. 4 minus 2, that is 2, okay. So is equal to 120 km per hour, okay. So this is same, okay. Velocity is as per the mathematically also and with the help of the graph. So finally I can say that this is acceleration is 0 here, okay. Thank you.